Welcome. In this session, we are going to do our first example of finding absolute extrema over an open interval or an infinite interval. It's again a geometric problem. I want to find of all open top boxes. So the box has 4 sides and a bottom, there is no top. Take such a box with a square base and a volume of 500 cubic inches. And I want the total amount of material used to be a minimum. So the amount of material is proportional to the surface area. So the area of the base plus the area of the 4 sides. So the problem then becomes to find open top box with square base and volume of 500 cubic inches and with the smallest possible surface area. A box has 3 measurements, length, width and height. If the base is a square, length and width should be the same. So let's call that x. And let's take the height to be h. Then the base is a square, x by x. Its area is x squared. There are 4 sides. Each is x. On the bottom, height h. So it's x by h. Each has area xh. 4 of them have total area 4xh. So the surface area of the bottom plus the 4 sides is x squared plus 4xh. We want to minimize this. But x and h cannot be independent because we want the volume to be a specific number, 500 cubic inches. The volume is length times width times height, or x times h. So x squared h should be 500. Now we have to decide which to use as our variable. In the equation x squared plus h equals 500, it's easier to solve for h. So we'll use x as our variable. Then I'm going to solve for h. So h is 500 over x squared. Substitute that in the expression we have for the volume, and that's the function I have to minimize. Let me simplify the function a little bit first. 4x times 500 over x squared is 4 times 500 is 2000, x over x squared is 1 over x, or x to the negative 1. So the function to minimize is x squared plus 2000 x to the power negative 1. They do not give us any restriction about the measurements of the box, which means x can be any positive number. X cannot be 0 because I have to divide by x, or the volume has to be a non-zero number. Obviously x cannot be negative. So I have to find the minimum of x squared plus 2000 x to the negative 1 over the interval 0 to infinity. Let's first find the critical values of this function in that interval. So I'm going to find the derivative of f. Derivative of x squared is 2x, derivative of 2000 x power negative 1 is 2000 times negative 1 x power negative 1 minus 1, or negative 2000 x power negative 2. This is always defined if x is positive. To find where it is 0, we'll just set that expression equal to 0 and solve. So if 2x minus 2000 x power negative 2 is 0, 2x equals 2000 x power negative 2, or 2000 over x squared. If I cross multiply, I get 2x cubed equals 2000. Divide by 2, and that gives me x cubed equals 1000. So x is 10. There is just one critical value. You can do the second derivative test or the first derivative test, but we'll use the alternate approach. It's rather obvious that this function f of x has limit infinity both at 0 and infinity. Because as x approaches 0, 2000 x power negative 1 or 2000 over x will go to infinity, at least if x is positive. As x goes to infinity, x squared goes to infinity. Since the limit at both ends are infinite, there must be a minimum somewhere in the middle, and it has to be a critical value. Since there is only one choice, that must be the absolute minimum. So x equals 10 gives me the absolute minimum. They asked me for the dimensions of the box, so I have to find the length, the width, and the height. X is the length and the width. The height is 500 over x squared. It's 500 over 10 squared, or 5. So the box is 10 inches by 10 inches by 5 inches tall.